Okay, today we're going to do 8.8 graphing linear inequalities. So you graph a linear inequality the same as a linear equation with a few exceptions. Okay, so you're still going to use your y equals mx plus b. You're still going to use, oh, that's not what I meant to have on there. You're still going to use your y equals mx plus b, where your slope and your y-intercept. It's just that now, instead of equals, you're going to have less than, greater than, less than or equal to, or greater than or equal to. So, graph a linear inequality the same as a linear equation with a few exceptions. Less than or greater than will have a dashed line because it doesn't include that line. It's kind of like the open circle when we did it before. Less than or equal to or greater than or equal to will have a solid line. Shade above the line for greater than or equals to, and shade below the line for less than or equals to. Okay, so let's just begin and hopefully it'll make sense. So y is less than x plus 2. So we don't have to solve for y, it's already in the right form. Our y-intercept is 2. Our slope is 1 over 1. It's puff positive, so up 1 over 1, up 1 over 1, the same as down 1 over 1, down 1 over 1. Now it is less than, it's not less than or equal to, so it does not include the line, so that's why you have to make it dashed. Okay, and then it says it's y is less than. Okay, so that means you're going to shade below. Okay, now as long as I know what you're doing, you can just draw arrows or whatever, as long as I know. So all of these points down here in the shaded area is a solution to this. Now if you wanted to pick a point like 0, 0 and plug it in, 0 is less than 0 plus 2, 0 is less than 2. Since that is true, that is where you shade, but you don't have to do that. I just like the rule that if it's less than, it's below, if it's greater than, it's above, if the y is on the left. Okay, so let's do a few more. So this one we need to solve for y. So we, excuse me, subtract 4x. So y is greater than or equal to negative 4x minus 3. So we go down to negative 3. And our slope is really negative 4 over 1. So you can go down negative 4 into the right one, or you can go up 4, 1, 2, 3, 4 into the left one. Okay, because that's one positive move, one negative move. 1, 2, 3, 4, and over 1. It's going to look like this. It is greater than or equals to, so it's a solid line, meaning the solutions are also on the line. Okay, and it says y is greater than. So if you think above or below, above would be up here. Okay. Now here, when we have y, we need to solve for y, and we have a negative 1 in front of that y. So we need to divide by negative 1, divide by negative 1. Remember our rule. Divide, when we divide or multiply by a negative, what do? We switch the sign. We switch the inequality sign. Okay, so since we're dividing by negative 1, we have to switch our sign, and it becomes negative 2x. Okay, so it's only when this number that's attached to the y is negative do you switch your sign, your inequality sign. So now we have negative 2x. So what is our y-intercept? Well, our y-intercept, remember, is just 0 because there's not 1 there, so it's 0. And we're going to go nice negative again, so down 2 to the right 1, down 2 to the right 1, which is the same as up 2 to the right 1. I'm sorry, up 2 to the left 1, up 2 to the left 1. Okay, and it is less than, and it's not less than or equals to, so we're going to have a dashed line, and it's shaded, it's less than, so we would pick below. Just like that. Okay, So we are going to graph a few more. Oh, let me get my right pencil here. Okay, so we go here, we look at our y-intercept, which is at -5, 1, 2, 3, 4, 5. And our slope, again, is negative. Okay, but we're going to have to go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1. And it is a solid line because it's less than or equal to, and since it's less than or equal to, it's going to be shaded below. Okay, if we come over here, again, we do not have a y-intercept. I mean, we have one, it's at 0, and I guess we're doing all negatives today for some reason. I don't know why. Down 1 to the right 1, up 1 to the right 1. I mean, gosh, up 1 to the left 1, I'm sorry. And this, see, I made a mistake there. This should be shaded. See, sometimes we get going too fast. This should be dashed. Okay? That's a good lesson there. So we get going too fast and we forget to go back and check. This should be dashed because it's y is greater than. Okay, and since it's greater than, we're going to shade up here on the top. Okay. Okay, I think we have one little word problem here. Apricots cost $3 a pound. Tomatoes cost $1 a pound. You plan to spend no more than $10. How many pounds of each can you buy? Okay, so we have, you can spend no more than $10. So it has to be less than or equal to $10. Okay, and we have apricots, so let's call apricots A. They're $3. 3A plus 1T for tomatoes is less than or equal to $10. Okay? Okay? So now we have to just solve for A. Alright, so, or T. You could solve for either one. Doesn't matter at this point. Okay, so let's just solve for T because that'll make it just one step. So subtract 3A. Subtract 3A. So that makes 1 tomato less than or equal to -3A plus 10. Okay, so now it's in y-intercept form. We go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. Okay, and it's going to be solid because it can include this line. Okay, and it is less than or equal to. So we would shade down here. So what this is saying is you could buy, let me get a different color here. You could buy one, because this is tomatoes on this side. And these are apricots. Okay, so you could buy 1 apricot and 1 tomato, or you could buy 1 apricot and 1, 2, 3, 4, 5, 6, 7 tomatoes and still be less than or equal to $10. You could buy 1, 2, 3 apricots and 1 tomato. There's all these different things you could buy. You could buy 0 apricots and 10 tomatoes. Okay, so any of those would work. Okay, so you would just show it using your graph. You wouldn't actually answer it. Okay, you would show it using your graph because there's so many different combinations. Okay, so let me over here. There's a little always later.